guys, welcome back to another video of Let's Make a Mario Game. Um, I apologize for the last episode. It's just something that I needed to do. But there's one thing, if you guys haven't read the description or anything, or annotations, I know maybe some of you guys may have canceled the annotations or something, but you're still getting errors or anyway about DLLs or something. Make sure let me open it up actually, because I forgot to mention it in the video, and I apologize. So if you go to your framework, if you go to bin, debug, you'll have all the DLLs that you need in here for the debug and release. So make sure you grab that and put it in your project, because that's something that we gonna be needing. So I apologize, I forgot to mention that in the video. But hopefully everything's straight out and everything works. If there's any issues, let me know, and I'll do my best, to help you guys out and what I can to make it work, basically. But anyway, let's go back to our project. I know in this video we are planning, or the plan is, to render something on the screen. So that's gonna be our plan. But before I do, I want to review a little bit of something that I have included. At least mostly it's the texture manager and managing stuff. So if we go to graphics, let's go to texture loader. I just want to review the texture loader really quick and what it's doing right now. So basically, it's texture loader manager. I mean the class, and it has an enum and that determines if it's a PNG or a JPEG. And we can add more to it if you want to use like bitmaps or DDS files or TGAs or stuff like that. But I did not include those because mostly I'm just going to be using these two. So we have the default constructor, and we have another constructor which includes the file name and the extension of that file. And you have a boolean that will read that file. We got the width, the height, bytes per pixel, bind, unbind. Mostly it's going to be used when we render something. And the rendering, when we're rendering to the GPU, the handle that we get from creating that texture. You set the name of this texture. You get the pixel buffer if you want to get it somehow. If you need it, and maybe you want to update the pixel or something like that, or stuff like that. So I know if you like read online, usually they delete it, but I don't really. But yeah, I'll just keep it. But anyway, the texture type is basically just something that it either is a GL texture 2D or a GL cube map or any other GL textures that are out there. These two functions will read the PNG or JPEGs and the member functions. So we go to texture loader. We got the default constructor, and this is a texture target. That's what I'm talking about. Either GL texture 2D or GL cube map or whatever it's gonna be. We have a texture loader which will do that and it will read the file at the same time. The reason why I do this though is that this will work in debug mode. Because before, if you just want to do this, do not copy what I do. I'm just showing you. If you just do this, this will work in debug, but this will not work in release mode because it will skip this. It will not even read it. It's gonna skip this line. And I had this issue when I was in release mode. I was like, what's going on? What's going on here? And it took me a while to realize that it is skipping this assert. So this is the reason why I'm doing this. And I just do this last part because it's my GL warnings level that I have it in. And since I'm not using it, it's just going to create an error. So I just put void read just to remove that warning. We got a destructor. We got the bind and unbind. This will read it. This mostly stuff right here is mostly to print it out in the command console. Oh, command line. Yeah. Command line, right? So it just creates the message, the name of that file, and the end just texture. This will set the name to that file name, and depending on the extension, we can either be reading PNG or JPEG. You set that message that we set on top, says successfully loaded, and then we print it out into the command line or command prompt. Just so they can tell us that it successfully loaded it. Then we read the PNGs. I'm not gonna go through all of this stuff because there's a lot of stuff going on and it's confusing. If it was a TGA or a bitmap, I probably would go into it, but I'm not gonna really go into it because it's crazy. There's a lot of stuff going on. But it's basically just reading the PNG and it creates our texture. And the same thing for JPEG and the getter functions and setter functions as well. And that's about it. If you guys have any questions of what's going on here, let me know. And I'll do my best to clarify. I'm just going through it really quick. And we also have, where's our managers? Our texture manager. Basically, this is what basically be managing our textures. We're going to be adding our textures, either be added by the class or by the object, or either by a file path, extension, and name. And the name is basically it's a name that is going to be set to the texture, so that when we get it, when we get our what is that function? Oh, it's right here. So when we get that texture, we will grab it by the name of where you set it to right here. So let's pretend it's Mario, the name of the file, and the extension is .png. And let's call it Mario Sprite, right? Mario Sprite .png, and you just set the name to Mario. So when we want to get that texture, then we just gonna pass here Mario instead of Mario Sprite.png or whatever. We're just gonna pass in whatever you named it right here. So that's what that's gonna be used for. And this function actually sets a directory where those files is gonna be at. And our manager, simple, destructor, deletes all the stuff. Add the texture, we set this so that it can print out to our command prompt. We create a new texture, we read it, and if it fails to read, then we delete it, and you say it print out to the command prompt saying the texture cannot be loaded. Otherwise, he successfully loaded it, and we set the name, and we add the texture to the texture list or vector list. We end other functions just add. Excuse me, I'm getting a call. Alright, I apologize for that. I was getting a call. But anyways, back to this. The other function is just basically adding the texture. If it's null, then don't return. Otherwise, add it to a list. Probably another good thing to put here is to check to see if it's already in the list. But it's not going to be really necessary. If you guys want to add it, go for it. I'm not going to because I don't want to waste this video too much time because we gotta get going because I don't want to let you guys down. But anyways, it gets the texture, loops throughout the lists, and finds the name of that texture by that name, and finds to return it. Otherwise, it just tells me that it could not be found. And this one sets a directory and it gets the instance. So, if you guys have any questions with that, let me know. If anything that I missed that you want me to clarify, let me know as well. But let's continue, guys, because we gotta get going. Alright, so in this thing, now we're gonna be doing is basically we're gonna be rendering something on the screen. So before we create our class, we have to go to some files. So let's go to them right now. Let's see, which one should we begin? Let's go to game component. Well, actually, you know what? Let's go to component.h. In here, well, you know what? Let's go entity. Forgive me. Let's go to entity. Right here, we can include our class. We can create a sprite batch up top. And inside, where's our render function? Render. There we go. We can pass in a pointer to sprite batch. Another thing, it's gonna be a render. We're expecting this to be 2D, huh? I'm just trying to figure out, like, alright. Let me look at my engine really quick. I think it's an app. Let me see rendering information. Render. Is camera in here? That way I can just... Yes, it is. Okay. That's another thing that'll be useful as well, is to pass in a camera. Let me put class camera. That way we don't have to get it from the engine, because that'll be kind of lame. So let's get camera, pointer, camera. So that's what we're gonna be passing in here. So just copy that if you want. Go to entity header, the CPP file as well. You're gonna go in here, and we can pass in sprite batch in here, and camera. It's gonna give you an error because it does not have it, but we will be adding it right now. So let's go to component H, component header file. We're gonna be including our sprite batching and camera into the render function. And we can apologize, someone's texting me. But anyways, let's go to component CPP file. We're gonna be adding that in there as well. And there's gonna be a little bug here. Well, for me, I'm just gonna put it just to make sure it's not gonna create it. A warning, because since I'm not using it here, I think it's the same thing with. Oh no, I am using an entity. We create these. Depending on your warning levels, either you want to do this or not. For me, my warnings are pretty high, so we should be having the same project. So we're pretty sure we should be doing the same thing anyway. But yeah. Remove from there. Okay, yeah. Get out of there. Get out entity. Component, entity manager. Let's go to entity manager. We also can be including it in the render function. Let's go to entity manager CPP file, and we can be creating it in sprite batch. Passing it into the render function. All the entities. Remove that. Let's go to game component. And in here, we can also be passing it into the render function. Go to the header file, you're going to do the same. Sprite batch and camera. Get out of there, go to game scene. You're going to pass it in as well because otherwise it's going to give you an error. Oh, and the same thing here. And you're going to pass it in here. And the camera. Okay, close the game scene since we're not going to be using it at the moment. The last thing we gotta do is go to engine CPP file, and in the render function, here you want to pass in the M sprite batch and the M camera, and that should be it. Let's see if there's any errors. Great, perfect. And if you run it, you should still get the black screen. Perfect. Okay. So now that's done. So now we finally be able to create our class. So let's go to add new item. No, not new item, my bad. Class, create class. Add class. And we're gonna call that sprite. And we can add it into the source folder, graphics. So you can add into the source folder and to the graphics folder, and add it, finish. Okay, so we have if and def, sprite, each, define, each, and you can do end if. Alright. Okay, now we can be including, remember include, we can include, where's that at? We can include components. We can go into sprite, you can inherit from components. And in here we can pass an entity. Okay. So in here we are. Let's see what we can be using. Are we going to be using? Yes, we're going to be using initialize. We can overwrite that. We're not going to be using update function here, at least at the moment we're not. We're definitely going to be using the render. Oh, my bad. We can have some private variables. Let's see. What are we? We definitely can be including. Let's include. Go to graphics and add a rectangle. A rectangle. Let me just pass in rect. What else can be needing here? We're gonna pass a texture loader and a shader. So I can say texture loader pointer. Pointer. Texture and shader pointer. The M shader. We're gonna create a public method called a set texture from file name. And you say const sharp pointer file name. We're gonna create another method called set shader from file name. And same thing, const sharp file name. What else do we need to create? I think that's about it. If I miss anything, I'll come back. So let's add these to the header file. Let's go to the header file. Pass an entity to the parameter of the constructor. Well, I can't type today. Entity. Actually, I don't even know if I'm gonna use this anymore. Yeah, because it's gonna happen when I set it. Yeah. You know what? Let's remove the initialize. We're probably not gonna use it. But anyways, in here, we're gonna say mTexture equals. Oh, we can include the texture manager. Let's include texture manager. Go to managers and add texture manager. We can include managers, shader manager. Okay, so now we're gonna go to texture manager, manager, get instance, get texture, and you can pass in the file name. I don't think I have that, do I? Let's include the assert.h, and you can pass in texture, and then you're gonna say mrec equals rectangle. You're gonna pass in 0, 0, pass in the float of mTexture, get width, and make sure you cast it as a float. You're gonna get the width and height and set it to the rect. Cool. And you're gonna set the M shader. No, that's not. Shader manager. Get instance. Get shader. And it's string, my bad. File name. And do the same thing with the assert. Make sure you actually grabbed it. And that should be about it for those two functions. Let's go to header file and remove that initialize because we're not going to use it anymore. I just realized we forgot something entity, but we can sheet it for now. Let's make sure, at least, let's render something on the screen at least. There's another thing, let's include camera as well. Let's include camera. Okay, so we're gonna get the shader. We're gonna say begin shader. Okay, there's a couple things that we gotta do here. Can I get math manager? Can I get the matrix here? Yes, I can. So we're gonna get a world. Translation scale. There's no rotation at the moment. So we got translation. Okay, build translation from our entity. Get position. We can build a scale. Let's call it a scale mat. Build scale. Oh, I don't have another one. Okay. So let's create a vector 3 scale and entity get scale. And we can pass in scale dot get x, scale dot get y, and pass the last one as 1, just to make sure it's always going to be 1. And set the world to translation times scale mat. One thing what I said earlier, I forgot to do something is I forgot to set the entity to have its own world matrix. That way I don't have to create it in here. I may create a class later that will handle this already, but just for now, so that we can render something on the screen, we can delay that for now. Okay, so now what we can do, we're gonna create set m shader. We're gonna set the matrix parameter. We're gonna say world matrix, and we're gonna pass in world dot as array. M shader set matrix. We're gonna set projection matrix. We're mostly gonna be orthogonal matrix, but let's just call it projection matrix for now. We're gonna set the camera, get ortho matrix, that's as array. Object has a qualifier. Oh, that's interesting. It's not const. Okay, let's go to math core really quick. Let's go to math core. Let's go to as array function. Ooh, this does not have it, huh? Interesting. Pass this as const. That way we're able to grab the const. Go to math core, find the as array function. Should be on top. Go to as array and make sure you pass it as const as well. I'm not sure if this is going to create an error or not, but if not, it's going to. So set the matrix parameter and set view matrix. The thing about view matrix, I believe it's going to be a. They just call this view matrix, but I believe it's going to be just an identity matrix for the time being. But for now, it's leave it like that. You can set m shader. Set sampler. We're gonna set a shader texture. And yes, 0. And we're gonna pass in the m texture. And then we can say sprite badge. Oh, I need to include sprite badge, my bad. Number include graphics, sprite badge. And we can say draw, and you can pass in rec. And M shader, and I believe that's it. World matrix, projection view, shader. Alright. Okay. So another thing. Let me double check about stuff. Okay. So in here, you can add. Also, go to your Super Mario directory. We can add a new folder. We're gonna call it shaders. And inside of here, we can add text document. And we're gonna call that texture underscore vs. Remove the txt and call it the glsl. And press yes. We're gonna do another one. Create or new. Where's it at? Text document, and call that texture underscore ps, and change that to glsl. Yes. Okay, we don't need that. So let's open it up or whatever you're gonna be using, either in Notepad C++, Notepad++, or regular Notepad, or wherever you're gonna be opening it at. Open the texture underscore bs.glsl. So we're gonna at the top, we're gonna name the version of this shader, and I believe, how do you say? Is it 400? Hold on, let me double check. Let's open another. Open recent. Yes, 400. Okay. You know, I might use that as a reference because I don't memorize all the times that. I don't always memorize that. What needs to be written in here. Anyways, we can. Okay, so it's key version 400, which makes it 4.0. We're gonna create some uniform values, which is uniform map4. We're gonna call that world matrix. Uniform map4 view matrix. Uniform map4 projection matrix. We can have a uniform. Actually, I don't need it in this one. Okay, so we can have some input variables. So we can be, you can call it layout, location, set 0. It just make sure that the location that's at 0 is always going to be the vertex and model space. So it's going to be layout location equals 0 in vec3 vertex model space. So layout, you can create another one and say location equals 1, as you guessed it. And you can pass in vec2, and this can be texture, chord, and model space. We're going to have some output variables, which for now is just going to be out our texture chords. And then we're going to create our vertex function. So this is main void. So in here, we're going to calculate the position of the vertex against the MVP. So we can have a map4 MVP, and it's going to be projection matrix times view matrix times world matrix. We're going to set that GL underscore position equals MVP times vec4 of input on a vec4 of vertex model space. and 1 as the last parameter. And then we can store texture chords. We're just gonna say text chord equals this thing on top. And then one thing we gotta do is that this is gonna be upside down. So we're gonna flip it. So it's gonna be texture chord y equals 1 minus text chord dot y. So this is basically we're gonna be flipping it upside down. And that's about it for our BS. So now we're gonna go to our pixel shader. Let me see if there's anything that I need in here. So we're gonna have input variables. We're gonna have n back 2 of text. Is it? Does it have a t? No. You're gonna create some uniform values, which is just a uniform. What's the name of it? Uniform sampler 2D. And we named it shader texture. And our next part is creating our pixel function, which is not that crazy. It's gonna be really simple pixel function. So the void main, and basically we can call it. Oh yeah, we need an output variable. Actually, I forgot. Hold on, we're not done yet. We're gonna call out vet4 and just call it frac color. So here vet4 frac color texture color texture, and we're gonna pass in the shader texture and the text chord. And then you just say, oh, you know what? It'll be simple. Instead of doing that, I just do this. Really simple thing going on here. So now let's go back to our project. Let's go to our game scene. There's a couple things we gotta do here. One, we gotta include our sprite. Oh wait, it's in graphics, huh? Sprites.h. One thing here, make sure we got game components initialize. That way, it initializes its base initialize function. Can I grab texture manager here? Okay, so now I have to include that as well. Number include managers, texture manager, number include managers, shader managers, sprites. What else? We could include engine. Or maybe the engine already has its app engine. Hold on. I believe engine has this, so we don't have to include that in here. Right? Texture manager. We have shader manager. Okay, great. Perfect. Alright, so let's include our texture manager. Get instance. We're gonna set root directory. We're gonna pass in textures. The root directory, which is where the folder is gonna be at, with all of our images. Let's go into our Super Mario game directory. I'm not sure if you guys have a texture folder, but if you don't, create one. And inside of here, you want to have a Mario sprite, which if you go to my GitHub, you guys saw the images folder in my GitHub in my last video, but let's go into it right now. Dang it, I don't have it open. Give me a second. Give me a second, guys. Oh, the thing's so slow. Okay, this thing is taking a while to load, but if you go to my GitHub and aware of this project, if you guys don't have the URL, it's gonna be in my description. But if we go to it, there's an images folder, and inside the images folder, there should be. Oh, my bad. Oh, there should be a Mario sprite. So make sure you grab it and push it in, add it into the textures folder, and it should be good. Hold on, I opened another project by accident. Okay, there we go. So make sure you grab the Mario sprite, and it should be good from there on. So now we want to include add texture. We can add, I believe it was called Mario Sprite. It's a PNG file, and I'm just gonna call it Mario. Let me double check that though. Mario-sprite.png. Now we're gonna have a shader manager. Get an instance. We don't need to set the root directory because I actually already set it inside the shader manager. I probably should do the same thing with texture manager, but that should be fine. You don't have to worry about that. If you want to add a texture, we're gonna call that texture. Just pass it as texture. Pass it as texture because inside this function it handles if it's a vertex function or a pixel function, pixel file, shader.glsl. So you just have to pass in the name of. Let's see, where's shaders? You just have to pass it beginning part that's before the underscore, and my at shader function will handle if it's underscore ps or bs, so you don't have to worry about it. And the last parameter is the name of the texture, which is basically the same thing as this. You will see in a bit right now. So we add all the files that we need. We want to go to engine, get engine, and we want to initialize our camera. But first of all, we have to create. Let's create an entity, pointer entity, add entity. We can pass an entity here. Float near is going to be 0 and far is going to be 1. That should be it about that. Now let's create our player. Entity equals add entity. We can have a sprite pointer. Sprite equals new sprite. We're going to pass an entity to it. Pass in a sprite. And set texture from file. And we're going to pass in a Mario, like I said earlier. Or whatever you named it here. You're going to pass it in here. Sprite. Set shader from file. And this can be texture. Which is basically this. From the second parameter where you added a shader. And let's add this. Set the position. And just say it's added at 100 at 100 for now. And if there aren't any errors, this should render something on the screen. And you don't have to worry about that. You can just run the program. Ooh, maybe I do. Maybe I should worry about it. Wait, hold on. Mario sprite. Is it a backslash? No, it's not. Why? Textures Mario sprite.png. Hold on. Why don't you read it? Textures Mario sprite.png. Interesting. Yeah. Why does that fail on me? Why does that fail on me? Break. Oh, it fails here. No, no, wait, what? Hold on, let me debug this. Break. Cancel, go back to game scene. Let me debug this then. Okay, so it breaks here. Oh, I know why. My bad. Okay, I know why. So, what you want to do, you want to call engine. That's something I forgot to do. Engine, initialize texture manager. And you want to do the same thing for the shader. And initialize shader manager. And that should work. That should work. Okay, so it didn't render anything, so we gotta figure out why. Okay, so we got the scale, which is 111. The world. Translation. 100, 100. Well, I may know why. What is the camera B matrix, by any chance? Yeah, there we go. The camera is an issue with the camera at the moment. So let's create another one. And here is called it view. Because a view mask should be an identity matrix since it's not a 3D camera. So what we want to do is just when you pass in the view matrix into the shader, you just want to pass in the view mat. I did mention it earlier when I was writing it. And there we go. We render something in the screen. It does not move, of course, but yeah. I hope you guys enjoyed this video. We actually finally render something to the screen. And it's kind of lame though, but we got it. You know, it's getting there already. And in the next video, since it's kind of already, it's a big video. It's already like 40 minutes, a little bit over. But in the next video, we will have player movement where it's gonna move back and forth. It's gonna jump, and it's gonna do all those cool stuff. But I hope you guys enjoyed this video. If you guys have any issues or issues or errors on this project, let me know, and I'll do my best to help you guys out. But otherwise, I hope you guys enjoyed it. Let other people know so that they can make a Mario game together with us. You know, make this awesome and amazing. More people the merrier, right? But anyway, if any and another thing also, if there's any feedback that you guys would like to give me, then just let me know. Just let me know because we'll be doing this together, and your input also is very important to me. So let me know if there's any if there's things in here that we could have done better, or I could have done better, and we'll figure that out together. So I hope you guys have a great day today, and I'll see you guys in the next video. Signing out.